All right, here we go. Yeah, I heard that one's going to be easy. All right, you guys, so here we go. You've got a circle, right? We're talking today about tangent lines and the slopes of tangent lines, okay? So what I want you to think about is a circle and some tangent line at some point P. So what does it mean to be a tangent line, that word tangent? What does that mean? Touches at exactly one point, right? And so if I were to draw this nice tangent line in here, it would touch right there, and then that's it. All right? My picture's not that good, but you get the idea. Okay, and so this is my tangent line T, and it touches at some point P. Okay? Now if you think about like the center of your circle, what was true about the radius and that tangent line? They're perpendicular, right? So in all like essence here, if you think about this, we could usually find the slope of that tangent line, right? Because what we could do is we could find, we know the equation of our circle, right? We know the radius of our circle. We know the coordinates of that point. We can find the coordinates of this point. We can find the slope of this line. And then we would just do opposite reciprocal slopes, and we could find the slope of that tangent line, right? So for a circle, we could figure out the slope of a tangent line. Okay? So what I'm going to take that now to is, what about if we have some other sort of curve? Okay, not a circle, but like a parabola or a cubic squiggle or some other, equations, other graphs. How could we find the slopes of their tangent lines, right? So let's look at this example here. We want the tangent line to a curve, okay? And so, for example, we're going to do something like anywhere along here, say right about here, let's say. I want to try and find, right, a tangent line right there. So it's going to touch it in one place. So it would come in and it would touch it something like this, right? I want to be able to find the slope of that tangent line. Okay, how am I going to be able to do that, right? Because I don't really know. I know the equation of this line, right? But I don't really know how could I do like the circle. I don't have a radius. I don't have an equation in there that could get me that distance, so I couldn't find the slopes. I couldn't do opposite reciprocal. Like, it's going to be a little trickier. So in order to find this is where we have to use limits, okay? Kind of explain it through to you. If you can grasp the explanation, awesome, right? Otherwise, what you can do is just kind of go through with the formula, memorize the formula, and be able to work it out for now. And eventually, this will all click, okay? But for now, I'm just going to try and get the explanation in there and see how you guys do. All right, so A is the x-coordinate of this point P. And so A is right here. And then we have some other point Q, okay? And so some other point Q that's going to be along this curve. And it goes, we're going to call this x, as its x-coordinate, okay? And so what's going to happen is I'm going to start to find the slope between those 2 points, okay? Well, the slope of those would be P of A and Q of x, right? I would just find, well, this would actually be the function, right? So this would be f and f. So I would find the slope. Well, slope would just be f of x minus f of a over x minus a, right? It's just my change in y over change in x, right? Along that line. Well, what we're going to do now, and this is where the limit comes into it, is we're going to start moving this point Q, right? And I'm going to move it closer and closer and closer and closer to point P. Right? You see where the limits are going to come in now. So what I'm going to do is as I move that closer, so as my x value gets closer and closer and closer to A, right, my y values are going to get closer and closer and closer to this f of A, right, of that y coordinate. So those are going to get closer and closer, these are going to get closer and closer, and as I get closer and closer and closer, I'm going to approximate, or I'm going to take the limit of the slope, okay? Because it's not really a line, it's a curve. It's not actually a line. So we can't actually take the slope of a line because it's not a line, right? It's a curve. And so there isn't a constant slope here. And so this will move closer and closer, this will move closer and closer, and that's where this concept of limit comes in. Okay, so again, if you're kind of like, not 100% sure what's going on, that's okay. This is the definition you need to memorize, okay? For the slope of a tangent line, and this is to any curve, Okay, so this is the slope of a tangent line. It could be to an actual line, which is easy, right? But usually we're going to do this to quadratics, to cubics, to radicals, okay, to other graphs like that. The slope is defined as the limit of, as x approaches a, of f of x minus f of a over x minus a. Okay, that's that difference quotient that we were looking at yesterday, which is just another way to write slope. Okay, this will give us the slope of the tangent line. Okay, the m of your tangent line. And a lot of times we try and find the whole equation of the tangent line. Other times we just find the slope of the tangent line. Okay. Questions before I move on to the example? Yeah.
Why does it say x is approaching a if it's really a approaching x?
No, it is actually x approaching a. So this is the x that's moving toward the point I'm looking for. Does that make sense?
Fa.
Oh, yeah. So f of x would be approaching f of a as x is approaching a.
Okay.
Makes sense now? Yeah.
So this is the same concept with like the deltas and stuff like that.
Yeah, it's all the same concept. It's all, with those deltas, we were getting really, 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 really close to it. With the table, when we were finding numeric limits, we're getting really, really, really close to it. So all of that idea is all limits, where you're approaching those values and getting really close to it, okay? All right, cool. Let's try the first example. It's asking us to find the slope of the tangent line to the graph y equals x squared at the point 2, 4. All right, so let's first draw our graph. Y equals x squared. There's my nice parabola. The point 2, 4, right here. They want the slope of the tangent line. So they want this tangent line right here. And they want me to tell me what's the slope of that tangent line right at that point. Okay? So this is where I have to use my definition. So the definition said the slope of the tangent line is equal to the limit as x approaches a of f of x minus f of a over x minus a. Don't worry about the 2 and the 4 just yet. Okay, we're going to start with this. I don't know why that's a little better. Okay. So all we're going to do now is start plugging in formulas. Okay, so again, the slope of my tangent line, I still keep this limit as x approaches a. F of x minus f of a. Well, f of x is this function right here. F of x is just equal to x squared. Okay? So all I'm going to do is plug in x squared. Well, what's f of a? I just plug in an a, so it'd be a squared. And on the bottom, it's just x minus a. Again, this is all that difference quotient stuff. All right, let's keep going. The slope of my tangent line is equal to the limit as x approaches a. What can I do with that numerator? Factor it. X plus a, x minus a. What happens to my x minus a's? They're gone. So now I just have the limit as x approaches a of x plus a. Okay, so now this is the point where this is the one part where I think people are like, well, what do I do now, right? What were we saying? We were saying that x was approaching a, right? X was getting closer and closer and closer and closer to a. So what we're going to do now is we're actually going to take this a and replace it for the x in here, okay? We're actually going to pretend that they get exactly so close together that they actually are the same value, okay? And so we're going to take that a and we're going to plug it into the equation right here for x, okay? So it's going to look like this. So, and I know if you're kind of like, I still don't get why we're doing that. That's okay. Just hold on. Just follow the steps. Take the a, plug it in there. Okay, because again, x is getting really, really close to a to the point where they are the exact same value. Okay, for all intents and purposes, they're the same thing. So when I plug it in there, what am I going to get? I'm going to get, when I plug in an a, I get a plus a, right? Which is 2a. And this is what I call, and we'll talk more about this later, a slope generator. That's a slope generator. That's a formula. That will find the slope at any point a, x value a, on this graph. So if I had like x equals -3, I would just plug in a -3 here and I would be able to find the slope there. If I had an x equals 0, I would plug in 0 and I could find the slope. If I have x equals 25, I plug in 25, and it will give me the slope. Okay, so that's the equation we're getting toward. Yeah?
So A is whatever x is.
You got it. And so now we want to find the slope at this point 2, 4. So what do we need to plug in for A? 2. That's my A. So I take that A and I plug it in here. So now my slope of my tangent line is just 2 times 2, which is 4, final answer. When you look at your picture, I always like to look at my picture to confirm that it makes sense. So it's telling me that the slope at this point right here on my picture is a slope of positive 4. Does that kind of make sense that that line could have a slope of positive 4? Well, sure. It's tilted in the positive direction. Looks kind of steepish. Okay? You definitely wouldn't want to get an answer that's negative, right? Or you wouldn't want to get like 1/3 or something, right? There's no way that's a slope of 1/3. Okay? So your answers should kind of match with your graph. Make sense? All right, so now we're just going to practice. I'm going to do one other example just because sometimes the directions change. Again, number 1 just said find the slope. 2 says find the slope. Jump down. You guys can go back and do number 2 later. But jump down to number 3 because number 3 now says find the whole equation of the tangent line. It doesn't just say find the slope. So let's find the whole equation, which isn't that hard. You'll just use point slope after you've got your point and your slope. Plug it back in. But let's do this one together just to have another one. All right, so x squared minus 2. That's just a parabola that's been shifted down 2. And they want it at the point 3, comma f of 3. Well, what is f of 3? Plug in a 3 here. Right? They just didn't tell you the y value. Good. So it's just 7. So they want it at 3, comma 7. All right, so this is what they're looking for, is the whole equation of that line. Well, we need to find its slope first. All right, this point 3, comma 7. There's my point. It's going to be a pretty steep slope. All right, so let's do our formula. The slope of the tangent line is the limit as x approaches a of f of x minus f of a over x minus a. All right, go ahead and work it out and then look up to check if you get the same thing I do. Don't forget parentheses. What happens? Yeah, you get the same thing. And later when we're able to find derivatives, you guys are going to realize we're doing this the long way right now is what we're doing. There will be a shortcut eventually.
Is it always going to be x plus a? That'd be nice.
No. Actually, the number 2 example is not x plus a. All right, so now what do I do at this step?
You
Plug in a for x. Whatever this is, I plug it in for x. So what I get again is a plus a, which is 2a. That's my slope generator. But in this case, we want it at what point for a?
3.
At 3. So I need to plug in a 3. So 6 is my slope. Does it make sense that this line over here looks like it has a slope of 6?
Yes.
For sure. Now we need to find the whole equation of that line. Well, if I have the slope and I have the point, I can just use point slope. What's my point slope equation?
Y minus y.
Equals m times x minus x1. Y minus y1 equals m times x minus x1, right? And so my x and my y's, x1 and y1 are 3 and 7. My slope is 6. And I am totally fine with you stopping there. It just said the equation of the line. It didn't say it has to be an mx plus b, right? This is an equation of the line. I'm happy, okay? Don't waste your time and make other mistakes by distributing and moving stuff around. I mean, you can if you want to, right? But it just needs the equation of the line. So I plug in the point, 3, 7, and my slope is 6. Questions?
So where did the x minus 3?
Where did this part? Yeah. So equation y minus y sub 1 equals m times x minus x1. So x1 and y1, 3 and 7. Cool. So I just put the 3 there, and I put the 7 there. Okay, good questions. Other questions? All right. You guys can work. Go back and do number 2, and then turn the page. Number 2 just asked you to find the slope. Okay, you've got a new equation. And then the next page, similar, you're going to find the slope and then find the equation of the tangent line. So it's really the same thing. They give you the point. Here they're giving you an a of 2. Here's your equation. Again, you're finding the slope and you're finding the equation. Finding the slope and the equation. There's your equation. There's your point. Okay? All right. Go ahead. I'll give you time to work. Try and finish it, and then you will not have homework.